Hey guys, welcome back. So the agenda of the today's session is that we are going to see these things. The first one is what is the meaning of the same network. So what is the meaning of the different network? We have discussed multiple time, right? So when we are communicating in the same network, nothing but the LAN, we require something called as the MAC addressing mechanism. If you want to communicate with one different network with the another different network, we require something called as the router, nothing but IP addressing mechanism, layer 3, right? So that we have discussed theoretically. So in this today's session we are going to see everything in terms of the practical manner, right? So what is the meaning of same network if we consider any IP address? So what is the meaning of different network, in which case we require the something called as the layer 3 device, nothing but the routers. You have seen that subnet masking, right? What is the real use case of the subnet masking? That we are going to see practically in this today's class. First we'll try to see that what is the meaning of the same network. So what is the meaning of the same network here is that, suppose for example this is my company, right? So this is my company or whatever it may be organization. Here I have the layer 2 device, nothing but the switch. So out of this I may have 3 device, 10 device, whatever it may be, right? So for each device we will be having the something called as the IP address we are going to assign to communicate from one device to the another device within the same area, right? So let it be this is my college, my university, so that is by within local area, right? So this is my local area network. Now what I'm going to do is, if I want to communicate from, so first let us understand what is the meaning of the same network. Suppose for example I'm going to explain this demonstration by using of the class C network. Suppose for example I'm going to consider this IP address something 192.168.1. This is the network series, right? So what is the network series? This is remain unchanged, it is the constant, right? But how host bit value is nothing but the 8-bit value, right? So 8-bit value means, right, so how many possibility we will be getting? 2 power 8. So 2 power 8 means we will be getting the starting IP address will be 0 1 2 3 4 5 6 7 8 9 and so on, so we will be getting the 255, right? Now see that first IP address is something 1.0, second IP address is 1.1, third IP address is 1.3. see that this the network will be remain constant, right? So this is the constant, then it is called as the same network. Suppose instead of writing the something 192.168.1, this will change 1 2 3 4 5 6 up to 255, it will vary, right? But if you are writing something instead of this one 192.168.2 something, if you compare this value with this value, it is the same network or different network? See, the bit value is different, here the network value is different, so it is called as the different network, right? So see that first 3 network portion should be same, then IP address we will be getting the 256, then it is called as the same network, right? So we'll see practically by considering the example, right? So let me open my packet tracer. Here I have the 3 pieces, so just I'm opening. So the IP address which I given to is 1.2, right? So class C, then default subnet was we know, right, 255.255.255.0. so let me, this is my something network. So 1.3 I have given here, so let me, here I'm going to give some IP address, it is 1.4, right? So now if I want to communicate from here to here something, this machine to this machine, happily I can able to communicate without the router. So why we can able to communicate without the router means, so see that here you observe in progress, right? See that after I'm going to forward the packet, what will be happen? Just concentrate it here, so it is successful. It means that successfully we are going to send the packet from the source to the destination within network, means just by using of the layer 2 device we are making the communication, right? But for example suppose see, right, so IP configuration, here I am giving the something called as the 192.168.1.5, let it be subnet mask this one, right? Now try to identify, right, so let me delete this one. Now try to identify this is the same network or different network. So what I'm going to say is, so the IP address assigned to this machine is 1.2, 1.3, 1.4, 1.5. Now try to identify these two are belongings to the same network or different network. Try to identify, please pause the video and try to find the solution. This is called as the same network or different network? See, this is called as the same network. Why? See, the first 3 bits are the constant. 192.168 is constant, right? So here we will be getting the IP address from 0 to 255. So out of this one, I have assigned 2 this one, 3 for this system, 4 for this system. See, network is same, right? So here also network is same. This fifth IP address we are assigning to this mean. It means that this is what we called as the same network. If you are communicating with the same network, just directly you can connect this switch with this switch, so that happily you can able to communicate with this mission to this mission without requirement of the router or layer 3 device. Because if you are communicating within the network, we don't require something called as the router, right? We will show you practically. Now see that 1.2, 1.3, 1.4, this is also same network, because first 3 bits are the constant, so which is also called as the same network, right? Now if I am trying to establish the communication from this network to it means within the same local area network we are connecting the one switch with the another switch, because these are the two different locations. By using the cable I am going to connect one L2 network with the another L2 network. So let me take the packet. So this is my destination source, this is my destination. See that it is in progress, right? Just if I am forwarding the packet, now see that what is happening, it is able to communicate, right? Now see that here we are getting the successful information. So from here, what is the one point you need to remember or understand is that if IP address network is same, so even though we can connect the 100 switches, we can perform the 100 devices, so that we can call this as the same network only. In this case we don't require something called as the router concept, right? Now we will say that when is called as the different network. I hope you understand what is the meaning of the same network. Now we will try to understand what is the meaning of the different network. Suppose for example, for this machine is 1.2, 1.3, 1.4. Suppose instead of giving this, I am giving for this machine is something 192.168.2.5 something. Now we try to identify this network is same or different. Try to identify. See that first 3 class C, first 3 are the network portion which is constant. If something is changing, it is nothing but it is called as the different network. So 192.168.1 is the one different network, then this is 192.168.2 is the different network. Now suppose for example this is one somewhere in the ECE block, this is somewhere in the CSE block of your university. Now somehow you are connecting this switch with this switch. Now we are trying to communicate from this PC to this PC. Now my question is that, first question is that this called as the same network or different network, right? So if same network means, your answer is same network means they should be happily able to communicate with this one. If it is not same network, then it is called as the different network. So if in case of the different network, this device cannot be able to communicate with this device. But if you want to communicate one different network with the another different network, in between one different network to the another different network, we require something called as the routing operation or router, that is nothing but the L3, which is works based on the IP addressing mechanism. We will consider, right? So what is your answer? Same network or different network, right? So we will see practically. Now see that this is 1.2, 1.3, 1.4. Earlier 1.5 same network means it is able to communicate, right? Now what I am going to do is, I am going to give the IP address is the different network, nothing but something I am giving the 2.5. So it means that this IP address I replace it with what? Something 2.5. Now this is the same network or different network? This is a different network, right? Now see that. So if I am sending the packet from here to here, in the previous case it is able to communicate, right? Now see that in progress, right? The moment if I click on the next, what is happening? Just observe here. Initially it is in progress, right? Now see that it is failed. It means that there is no communication from the one different network IP address with the different network IP address if you are using the same local area network concept. Now here what is required is that if you want to communicate one different network with the another different network, we require something called as the router operation, right? Now you understand when to use the router, when not to use the routing concept. Router is nothing but the L3 devices which works based on the IP addressing mechanism. So let me quickly take router, right? So let me give the connection, something I am going to give the connection. See that what is this interface? G0 by 0. On this interface we need to give the IP address, right? So let me take one more wire. This is 0, G0 by 1. So from here what you have to understand is that, one second, so let me crop this one. See this is 192.168.1 dot network. So this is 192.168.2 dot network. So now see that if you want to communicate this one, the first it will go to here, it will initially check this system with this system. If you don't find the destination devices, then packet will be transferred to your router, right? Now if you see that by default it is the red color, right? It means that it is not have the connection. As we told that router will works based on what? IP addressing mechanism. Each interface, suppose for example, if you take this router, if you have something 3 connections, each connection will be having the some interface name, let it be G0 by 0. It means that gigabyte Ethernet port 0. Something G0 by 1 means gigabyte Ethernet port 1. G0 by 2 means gigabyte Ethernet port 2. Right, so each port we are connecting to the router. Then one more thing, each port will be identify something called as the unique identification mechanism. Let it be 1.1, this will be 2.1, this will be something 192.168.3.1. so this router having how many interface? This is the first interface, this is the second interface. Each interface will be identify what? IP address. But this interface we connected to which network? 1 dot network, right? It means that we will be getting the IP address from up to 255. So out of these 255, we can assign any IP address to this router interface also. See that this is L3 device which will work based on the IP addressing mechanism. Now see that what is the IP address? See, I have assigned 1.2, 1.3 for this system, 1.4 for this system, right? So out of remaining, so from 1.5 to 1.254, you can assign any IP address to this interface. See that FA0 by 1 interface of this particular switch for this system, I assign this 1.2. Like this here also we need to assign the IP address. So let me, I am going to write the IP address something 1.1, right? So now, so this is for what? Which network? This is for 2 dot network. It means that we need to assign something. Let it be here, I am going to assign something 2.1, 2.2, 2.3, something 2.2, 2.3, 2.4, right? So now this is 2 dot network means, so for this interface also nothing but G0 by interface, we need to apply the IP address is 2.1 or in between 1 to 254 you can apply any IP address. Now see that. Now for example, let it be my source is something but 192.168.1.2. this is my source mission. So where it has to send the packet, the destination is something 192.168.2.2, something from here it should send the packet to the here, but this is the different network, this is the different network. So here we have something called as the router concept. Now see that the moment it sends the destination IP address, first it will go to the switch. The moment it reaches to the switch, it will check with database whether we have the destination of the 2.2 is related to here or here. It won't find the answer. Now the duty of the switch is that if you don't find the answer within the local network, just it will forward the packet to the router. Now router has to take the decision where to send, right? Now out of this router, see that for example, if the packet is from this network 1.1 need to send to the something 2.1 network, then router will take the intelligent decision. So here it should not send to here 3.1 network, right? So router will forward to here, right? So in L3 we are going to consider, right? So we have something routing protocols, right? So static routing, dynamic routing. In this case I will explain so how router will perform the shortest path, logical IP address assigning, how to find out the best path. That part we will discuss later. Now it will go to the router, then router knows where to send this one. So if it is 2.2 related means it will send this via this interface, it will receive at the switch, then finally it will reach to the destination, right? Now we will see practically. So see that for this interface I am giving this network, nothing but, let me open this one. So we have this G0 by interface, right? So by default it will be off position, we need to make it as the on. So I am giving IP address 192.168.1.1, then subnet mask is this one. See that. So if you are familiar with CCNA course, something like this, so these are the command we need to write inside of the terminal. So just for example, here I am performing the manual operation, right? So what is the IP address we try to give? 192.168.2.1. so just I am telling this interface, guys, this interface G0 by 1, right? So 2.1, this is the subnet mask, right? Now see that earlier it is in the, right? Now see that it is in the no connection means red color. Now it is turned to green color, right? So now what we will do is, right, so that is, what is this IP address? Let it be 2.2. This IP address is something what? 1.2. Now just let me take the packet, right? So let me take the packet. So I just want to communicate from where, right? So this is my source mission, this is my destination mission. So you will understanding one more interesting thing. So still it is in progress. Now it is something like it is failed, right? Why even after performing giving the exit gateway, for this one exit gateway the router will take the decision, why it is again failed means here we need to, it means that if we are going to make the mistakes, we are going to learn the some more things, right? Now if you observe here, the moment in the PC0 we have only two things given. What is that? One is IPv address, another one is the subnet mask. Now see that if it is not your network, then where the packet has to be routed, this is also one more important point. See that if it is not within network, where the packet to be routed, see for this connection there may be one more router here, one more router here, right? So but if you are not here within the network, then where we need to send this packet means we have something called as the default gateway. It means that if you are coming from your block, if you want to exit, where you want to exit, either this side, back side of your college, or main gate of the college, that we need to mention, right? So that is what we call something in right, in example, that is that use case we calling as the default gateway. So if it is not here, where it should go? 1.1, right? Now see that 192.168.1.1. see here you understand one more thing, the what is the use of the default gateway, which is used when communicating from the one different network with the another different network. Now this is 2.2 network, right? Now see that. So now you tell me what is the answer here, what is the default gateway we need to write for this device, right? What is this one? 192.168.1.1 or 2.1? Yes, the answer is 2.1. Why? Because if it is not here, then it should go via this line, nothing but the exit interface is the 2.1, right? So after giving the default gateway, so let me take, this is my source mission, this is my destination. We can see that it is in progress. Now see that what is happening, going switch, it is checking switch database, it don't find any destination IP address related to the switch database, so it is sending the packet to the default gateway is nothing but the 1.1. now R3 device, nothing but the router will take the decision where to send the packet. So it knows that where to send the packet, it delivers the packet to the switch, then from the switch it is going to deliver to the destination devices. So once it is done, you are getting the acknowledgement. The acknowledgement is very important, guys. The reason is that the transmitter does not know when the received information is successful or not. See that acknowledgement also received successfully, so finally we are getting the successful information, right? So here you have learned the three more things. So when is what, when we require something called as the default gateway, right? Now suppose for example we will see one more concept is nothing but what is the subnet masking, right? So how subnet mask identify the IP address range. So what is the meaning of this one is, so in the previous class we have divided something, right? So what is the subnet mask? If you remember, 255.255.224, right? So if you are directly coming to this video, please watch the previous video, there I have explained the fixed length subnet masking, so that you will understand this one. To explain the how subnet mask will be identify the range of the IP address, so this is required, right? So this is my subnet mask. So what is the network? Each network will be having the something 1.0 to 192.168.1.30. What is that value? 31, right? So this is the starting IP address, ending IP address, right? Now see that what will be happen. So it means that when you are considering the subnet something 255.255.0, the maximum number of systems that can be allowed to the host machine is 256. But instead of 0, if you are considering the 224, this is nothing but the /27 notation CIDR value, classless addressing mechanism. So we can able to give only 32 IP address for the each network. Now see that what will be happen if you are giving in between 1.1 to 1.30, it means that 1.1 to 1.30. by using this subnet, what will be happen, if you are giving something, first system IP address is 1.1, then next system address is something 1.50, then whether they will be able to communicate or not, we will see practically, right? For this, just I am opening the system. right? So IP configuration, something I'm going to give something 1.2 something. So before that, let me delete this network. I don't require this one. Set. Fine. So let me consider this one. So something is 1.1, the series is something, I'm giving something 224, right? So I don't require default gateway because I don't have the router, right? So let me take this one, right? So let me 1.2 there given, 1.3, so let me 224, right? So IP is 1.1, this machine is 1.3, then what is the subnet mask we have given? 224. It means that it will allow the only 32 IP address. Now we will see that practically. So let me take the source, destination, see that it is in progress. Let me forward the packet. Now here it is successful, right? Now see, subnet mask is working. Why it is working? Because the allowed IP address range is from 1.1 to 1.30, right? Now what we will do is, we will consider the some other scenario. Let me here something value something 1.50 other than the range, but subnet mask is the same only. Now just I'm taking the packet, so 1.12, this is now 1.50, right? Not 1.3. Now see that what will be happen, it is in progress, right? Let me forward the packet. So see that it is failed. Why it is failed? So as per the subnetting concept, we are dividing one single network into the multiple portions. See that if this one subnet means, if you are giving the subnet mask 224 means, the value if it is start something 1.1, then it should be ended with only below 1.30 only. This is the meaning of the subnet mask, which is used to identify the what is the range of your network host IP address. I hope you understand clearly, right? So this is the most important thing which you need to understand if you are learning the computer networking or CCNA concept. This is the most important concept. Thank you guys.